my dear student, I'm Saktwala from Educare TZ. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on the topic of rotation of a rigid body for our subtopic of center of masses. So, my dear student, before we proceed with our discussion here, we are supposed to remember where we ended on the last session, the first session on this topic. So, on the first session, my dear student, we tried to see the introduction of the rotation motion. And finally, we tried to observe the meaning of the rigid body. And we said that this rigid body is an object that does not change their shape and the influence of the force or under the application of the force. Their shape should remain constant. It's what we said on the rigid body. And after that, we try to see the meaning of the concept about the center of masses of a rigid body. So nowadays here, we are going to look to proceed with our discussion where we ended on the last session. As we try to see on the last session, we tried to demonstrate the first equation, and we said that imagine we have an irregular object, and that irregular object tried to rotate around a fixed axis. When they revolve, it means the particles that are found inside the rigid shape or the rigid body, they contain it is only a mass. That is why they can act from the axis of rotation up to the particle where they are being originated. They form their own distance. That is why we tried to demonstrate on the last session. We said that, my dear student, if we wanted to obtain the force when the body tried to rotate on around a fixed axis, the force total must be equal to force 1 plus force 2 plus force 3 plus dash force the nth terms, the number of the forces or the number of the particles that are found inside the rigid body. And after that, we substituted the value of the forces, and we say that the force 1 must be represented by mass 1 times the acceleration. And we say that overall, the force must be equals to the mass 1 times the acceleration. Then we add by mass 2 times the acceleration. We add by mass 3 times the acceleration. Then we add by dash addition mass n times the accelerations. So equation number 4.1 here, that is what I have tried to say, to repeat again. Can be expressed in terms of the second derivative of the displacement. So this equation, we should express it in terms of the second derivative of the displacement. Kwa ile equation ambayo tulipata ipo in terms of the acceleration, now we are supposed to express it in terms of the displacement. It means we call the derivative. Kwa kusema kwamba badala ya kuandika acceleration, tunajua acceleration must be equal to the derivative square of derivative t square. So let us formulate it in forms of displacement of derivative of the displacement, the second derivative of the displacement. So summation of the force, we say that must be equal to to second derivative, to second derivative of the displacement of this mass 1. It means we factor out this derivative. It means itakuwa ni derivative square, the second derivative divided or derivative of t. Lakini we differentiate with respect to the time, as we try to observe here. Mass 1, that is what we tried to see on an irregular shape, plus mass 2 times x2. If we add by mass 2 times the x3, then we add dash addition of mass n terms times the distance of the n terms. That is what we try to observe. So after that, my dear student, because if we try to demonstrate here, we should say that because this mass 1 and this mass and also their distance, they can vary. Now we are supposed to assume that they can be they can start from 1 up to the n stems. Instead of writing up to the n stems, we should represent it in terms of the summation. Kwa tutasema kwamba kumbe the summation of the force must be equal to the summation of their masses, lakini of their masses and also the acceleration. This acceleration here should represent the acceleration of the center of the masses. Kwa yule acceleration atarepresent yule atarepresent the acceleration of the center of their masses, ambao tunamdefine hapa. Ukiapply definition derivative hapa utaona sana sana atarepresent the acceleration of the center of their masses. So here, my dear student, we see that this mass should vary because inside the irregular object we have several many particles. If we have many particles inside those regular shape, we could say that this must be I. It means I should start with 1 mpaka n stems. Kwa kama ata start from 1 mpaka n stems, basi unaweza ukamrudisha kama pale kwamba akiwa 1 atakuwa ni m1 times the acceleration ambayo ana represent acceleration wa center of masses. Also this if I change into 2 itakuwa ni mass 2, utapata ile formula yetu ya huku juu. Therefore the second, this will be the second equation of our first topic, and we could say that summation of the rigid body, the summation of the forces must be equal to the sum of the mass I. It means from I equal to 1 up to I equals to n times the concentrated the mass at the acceleration of the center of the mass. So after there, my dear student, here as we try to observe where AM represented the acceleration of the center of masses. As I told you that this ACM stand instead of the acceleration of the center of masses. Kwa hiyo ana represent the acceleration of the center of mass. So after there, my dear student, since we know that this acceleration of center of masses is equal to second derivative of the second derivative of the displacement with respect to the time. Kwa baadaye ya hivyo sasa tutamwambia kwamba huyu ACM ana represent the second derivative of displacement with respect to the time. And the m1 x1 plus this one m2 x2 plus m3 x3 plus dash dash plus mn xn must be equal to the summation. This should be equal to the summation of mi. I start from 1 up to the n stems times this xi. Kwa tutasema sasa kwamba kumbe sasa hawa summation hawa m1 x1 mpaka mn xn watabini represented in terms of the summation. Kwa tuta apply summation, tutasema ni sawa na summation from I is equal to 1 mpaka I is equal to n wa mi alafu xi. So equation number 4.2 that represent the forces in terms of the summation. Reduce it to this one. That equation should be reduced up to this one. Kwa hiyo equation tutaweza kureduce, mwisho wa siku tutapata hiki kitu hapa, kama tutapata kwamba kumbe huyu acceleration huyu displacement along to the x-axis must be equal to the summation. It means it must be equal to the summation from I equals to 1 up to I equals to n wa mass I times the xi divided by the summation of I to 1 of I equals to 1 up to I is equal to n wa mass I. This should be the equation number 4.3, my dear students. So after this one here, this which represented the equation number 4.3. After this here, now we were supposed to, my dear student, to assume that this equation here should represent this should represent the mass. This should represent as the equation number 3 on our fourth topic here. So similarly along to the y-axis, let us go and see along to the y-axis when the center is on the vertical axis. We say that this when it means when the irregular object tried to rotate vertically, the center of the mass along the y-axis must be equal to the summation of from I equals to 1, from I equals to 1 up to I equals to n times the mass I times the yi divided by summation from I to equals to 1 up to I equals to n times the mass I. And this, my dear student, should be the equation number 4 as we try to observe. This should be the question number 4 on our topic number 3. On our topic number 4 as we try to observe here. So for the two-dimensional plane figure, the coordinate of the center of mass is at x along it is at x comma y. Kwa ile center of the masses katika two dimensional, if we have the two dimensional dimensional plane figures, we should obtain that we should obtain that the center the coordinate of the center of mass at this point should be equals to x. X it means the center of mass along to the x-axis, comma to the center of mass along to the y-axis. But both of them involve their own definition. We tried to observe that the center of mass along to the x must be equal to the summation from I to n or mass I times the x I divided by summation I n up to n or mass I. And this along to y-axis, we tried to observe a similar one, which we allocated as the equation number the equation number 4 as we tried to see. So my lovely students, this if we want and it is distance from the origin. If we have the distance from the origin, it means from the regional up to the centenary point. Now we should consider the displacement, the radius. Kwa tutaconsider ile radius kwa obey the Pythagoras theory kwamba the r at the center, the resultant r which is located at the center from the original must be equals to the distance of the center of the masses from along the x-axis square. Then we add along to the y along to the y-axis as we try to observe. So the distance along to the center of the masses, if we have two dimensions, must be equal to the radical of the axis of the x along to the center of the masses square. Then we add by the y along to the center of the masses square. This should be the equation number 5 on our topic number 4 as we try to observe here. So for two concentrated particles of mass 1 and mass 2 with position vector itakuwa ni hii hapa. If we have two concentrated particles, let us see that we have the irregular shape, and those irregular shape have connected with the particles. We have two connected particles. That we have two particles inside the irregular shape, and those particles are connected each other. They consider they must contain their masses. It means particle wa kwanza ata contain mass 1 na particle wa pili ata contain mass 2, lakini with their position vectors ambao atakuwa ni a vector of R1 and also a vector R2. Kwa ile particle wa kwanza ata contain mass 1 pamoja na vector R1, lakini particle wa pili ambao bini connected pale ata contain mass 2 and also the vector R2 as we try to observe in figure number 4.2. So the center of mass is given by this one. So we obtain the center of mass by written in the form of this one. The center of mass for this vector position we could indicate by saying that area of the center of this or area along to the center of mass must be equal to m1 r1. It means times the vector or r1. Then we add by m2 times the vector of r2 as we try to observe. Then we sum by the mass plus mass 2, mass 1 plus mass 2. This definition here, my dear student, come from this figure. Along to this figure number 4 point, along to this equation 4.4 and also 4.3. Now we are supposed to imagine that because we have two masses, now it should be that R or center of mass, the vector R, must be equal to mass 1, R1 vector, plus to mass 2, R2 vector. Then we add it by their masses, as we have tried to see here. The sum of the masses can be stay below. So after that, my dear student, we should label that this should represent the question number 6 on our topic. Or here, iteki and shumu as the question number 6. So after that, my dear student, here, where R1 here, the vector R1 should be equals to the summation of the vertical axis and also the y axis, ambapo atakuwa R1, the vector R1 atakuwa ni sawasawa na vector of x1 jumlisha the vector of the y1, and also R2 must be the vector R2 must be equal to the vector x1 if we add by the vector vector x2 if we add by the vector y2 that occur around the two components as we tried to observe. So after that, my dear students, we have our figure here. Let us try to observe our figure, how this formula gives us the figure. As we can see, we have the figure that represents the two particles system. We have the two particles that are in the system. That is what we try to observe. So we have the two dimensions along the y-axis and also along the vertical axis. So along to the y-axis here, we have our particle. This is our particle that are in irregular shape. This is a regular object. And this we have the two particles that are connected together as we tried to see on our concept. We have the particle 1. And this particle 1 is connected together with the particle 2. Particle 1 involve the mass 1, but particle 2 involve the mass 2. But all of those, they extend from the original position. So transitions may extend from the original position. As we try to observe, my dear students. Now we see the particle 1 extend at the distance R1 from the vector R1 from the original position, as we try to see. And also M2 extended at the distance or at the vector R2 from the original position. But we have their resultant, as we try to see, that mass 1 here along the vertical axis extended at y1, and also mass 2 along to the vertical axis extended at y2, as we try to see. But along to the x-axis, mass 1 extended to x1, and also mass 2 extended to the x2. Therefore, my dear student, we try to find the resultant. How can we get the resultant? Now, the resultant of their vector here should be equals by the this summation, as we try to see here. Must be equals to mass 1 R1 plus mass 2 R2 divided by the summation of their masses, as we try to see here. So after that, my dear student, we should say that the positioning of the center of mass depends upon the shape, size, and also the distribution of masses of the body. So if we want the positioning of the center of mass, the positioning of the center of the masses must depend on the shape of an object, or the shape of the masses, the size of an object, also at the distribution of the mass. Kwa lazima iweze kutegemea vitu vitatu. Kwa utaambia what is the factors on which the center of the masses depend. Utamwambia kwamba inakuwa ina depend kwenye shape of an object, the position, the size of the object. It means the size of the masses, and also the distribution of the masses of the body. That is what it tried to depend. So in addition, the center of the mass body within lie within or outside the body. Kwa addition, hii center of the body it must lie inside or outside of the body. Kwa hiyo yenyewe inakuwa haitegemei, inaweza lie inside the body au inaweza lie outside the body when the external force is applied to the center here. So my dear student, the position of the center of the mass is the motion of the whole. As we try to see that all of this we are talking about the factor on which the position of the center of the mass should depend. That is an idea that it doesn't contain the similar position, but the position of the center of the body can vary. It can occur inside the body or outside the body. So my dear student, by saying that this is the end of our session here, now I would like to welcome you again for another session. I wish you all of the best. Have a nice moment.